All right, so you should have this pink review downloaded. This will take us about a half an hour. And then after this, we will do the question and answer time from Friday's assignment. So on the review, I put some green boxes together. Remember, when you convert from degrees to radians, that would be your ratio. And then from radians to degrees, this would be your ratio. To find coterminal angles, you would add or subtract a revolution, which is 360 degrees or 2 pi. If you use your arc length formula, that angle theta must be in radians. Then there are some even and odd functions. And then we have the reciprocal identities, the quotient identities, Pythagorean identities. And then here are your 6 trig functions for right triangles. And then I added the unit circle. These are your angles in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, so the first question says, convert the angle from degree measure to radian measure. So we're going to use that ratio of pi over 180 degrees. And what happens is the degrees are going to cancel out and you would multiply across. And then you would try and reduce your fraction by a common factor. Well, both of them can divide by 15. So the equivalent form is pi over 12. Then it says, identify the quadrant in which this angle falls. So if we go back up, this would be 15 degrees. So this represents an angle in quadrant 1. All right, next question. Convert from radian measure to degree measure. So we're going to use that ratio again, but we're going to change it from 180 degrees is now in the numerator, and then pi is in the denominator. We can cancel the pi's, and then we can reduce 180 degrees and 6 by 6. So that'll become a 1, and this becomes 30 degrees. And now we can multiply across. So negative 5 times 30 degrees is negative 150 degrees over 1. Then it says, find the quadrant in which it falls in. So if we go up, this would be negative 30 degrees, negative 60, negative 90, negative 120, negative 150. So this angle right here is negative 150 degrees. Which quadrant does it fall in? It falls in quadrant 3. All right, next step is to work with coterminal angles. And we want our angles to be between a positive 360 degrees and a positive 2 pi. So we need to add a revolution to that negative 445 degrees. So we're going to add one revolution and see if we get an angle between 0 and 360. And we get a negative angle. So that means we have to add another revolution. Now we have 275 degrees. So this angle is between 0 and 360 degrees. So that would be our coterminal angle that we want. The second problem is in radian measure, and we want the angle to be somewhere between 0 and 2 pi. So this is a bigger angle, it's larger than 2 pi, and notice the denominator is 4. So I'm going to change this to 8 pi over 4. 8 pi over 4 is equivalent to 2 pi. So what we have to do is we have to subtract our revolution. We have to subtract 2 pi or 8 pi over 4. And we get 5 pi over 4. So these are coterminal. All right, next question says find the length of an arc on a circle whose radius is 10 feet with a central angle of 135 degrees. And we want to find this arc length right here. So we have that equation up above, S equals R times theta. But this theta needs to be in radians. Our angle is not in radians, so we have to convert it to radian measure. So we're going to take 135 degrees and do our pi over 180 degrees and convert it. The degrees are going to cancel. And then you're going to simplify it to give you 3 pi over 4. Now we're able to use our formula. So arc length equals the radius, 10 feet, times 3 pi over 4. And it's asking us to have the answer in terms of pi. So we'd multiply across. 10 times 30 pi, or 3 pi is 30 pi, over 4 feet. So that's our arc length. Then it says round your answer to 2 decimal places. So we'd have to type that into our calculator. All right. We're going to move on to the unit circle. Here are just some of the angles on the unit circle. Remember, pi over 6 is equivalent to 30 degrees, and pi over 3 is equivalent to 60 degrees. So let's start off with question 5. We want to find the exact value for the sine of pi over 6. Remember, on the unit circle, the point x, comma, y is the cosine value and the sine value on the unit circle. So if we want to find the sine of pi over 6, we're looking for the y-coordinate of pi over 6. So here is pi over 6, and that y-coordinate is 1/2. So the sine of pi over 6 exactly is 1/2. The cosine of 2 pi over 3 is going to be your x. So you go and find 2 pi over 3, which this is 2 pi over 3. Then you look for the x, and that's negative 1/2. Another cosine of 3 pi over 2. It's your x. So you want to find out where is 3 pi over 2 on the unit circle. It's right here. And that's your x. So sine and cosine, you can look quickly at the unit circle. The other 4, you have to do a little bit of work. The other 4 trig functions. And that's what we're going to go into next. So secant. Secant is the reciprocal of the cosine. So we're going to be going 1 over x. So we have to find 5 pi over 6 on the unit circle. This dot is 5 pi over 6. So we're going to take that x value and we're going to reciprocate it. And when we reciprocate it, we get a denominator that has a radical. So we have to rationalize it. $24. How about all your technology stuff? You can do your technology stuff next, your media.
So we only have one.
Sorry, just 1 second. Yes?
We only have so like we only got. I already did the media. We only got like one thing inside of homeroom, and I just checked again, and there was something else.
So why don't you work on your other media assignments?
But I already did the one for today and 2 other.
Okay, why don't we just finish them all up because it's only 10:30 right now, and then you're done, and then we can celebrate. Okay? All right.
But I do not know how to do one of them.
Okay, so maybe in a little bit then we'll have Blakey or Lexi help you, or I'll help you later, okay?
Okay, I'll do one of them that's easy.
Okay.
So I only have one left.
Okay.
Yeah.
Sounds good. All right, good job, Reagan. Sorry for that. That was just my little Reagan, my 10-year-old, updating me on her schoolwork. So to do the tangent, you're going to do the y over the x. You want to find 4 pi over 3. So we're going to count. Pi over 3, 2 pi over 3, 3 pi over 3. This is 4 pi over 3. So we're going to take the y, negative square root of 3 over 2, and divide it by the x, negative 1/2. And now we're going to keep change flip. We're going to keep the negative square root of 3 over 2. We're going to change it to multiplication, and then we're going to flip it. And then what happens is the negative times a negative turns to a positive. The 2's cancel out, and when you multiply across, you get exactly the square root of 3. Cotangent is the reciprocal of the tangent. So it is x over y. So we want to find pi on the unit circle. It's equivalent to 180 degrees. So we're going to take the x over the y. So negative 1 divided by 0 is undefined. All right, next question. We want to find the cosine, and we're giving you the sine. And the angle falls between 0 and pi over 2. And we want to use the Pythagorean identity. So here is our 4 quadrants. Here's 0 radians, and this is pi over 2. So our angle falls somewhere in this first quadrant. And we want to find the cosine. We know the sine is 7/8. We want to find that cosine. So we're going to solve using that Pythagorean identity. So sine squared plus cosine squared equals 1. And we're going to substitute 7/8 in for the sine of t. So we have to square that 7/8. So 7/8 times 7/8, so 7 times 7 is 49. 8 times 8 is 64. Now we're going to move that 49/64 to the right side, so we're going to subtract. And then we need to simplify that right side. Well, those fractions are not alike. So we're going to change that 1 to 64 divided by 64. So now 64 minus 49 is 25. Now we need to undo that cosine squared. So to undo a squared, we're going to square root both sides. And then what we get on the right side, since those are both nice perfect squares, we get 5/8. And then we have to choose the appropriate sign. Is it a positive or a negative? Well, in quadrant 1, the cosine, the x value, always has to be a positive number. All right, moving on to right triangle trig. So here's a right triangle, and we want to find the length of side A. So this is side opposite to angle A, and this is side adjacent to angle A. So we want to choose the appropriate trig function. Well, what works with opposite and adjacent is tangent. So we say the tangent of the angle, opposite is A, adjacent is 100. And then we solve for A. So to solve for A, we're going to multiply both sides by 100. And then you're going to round to the nearest whole number. So you want to make sure your calculator is in degree mode. All right, here's another question. We have our surveyor, our angle. This is side adjacent, and we want to find the distance across the lake. So we're looking for side opposite. So I'm just going to let that be the letter X. So the trig function that works with opposite and adjacent is tangent again. And then we solve for X. So we're going to multiply both sides by 50. So X to the nearest meter will be approximately 31 meters. All right, here is our last question on the review. The Washington Monument is 555 feet high. If you're standing 1/4 a mile away, or 1,320 feet, so here you are, what is this angle of elevation? So this is side opposite, and this is side adjacent. So the trig function we're using again, tangent. So opposite over adjacent. Now to find an angle measure, we're going to use inverse trig. And then we would use our calculator, make sure we're in degree mode. Go second tangent, tangent inverse. And says to the nearest degree. So that would be 23 degrees.